Hi all, hope you had your coffee. For this lot today, we're going to talk about legacy code, yeah, but also about how to work together even more, yeah. But first of all, who's talking to you? My name is Giorgio, and I consider myself a tech lead by role, but also by spirit. And what I usually work on is not just getting stuff to work, but making software easy to change, or in a wider context, helping teams doing it, rather than trying to work alone. On the side, I grow some basil and parsley on my window in my remote office. But let's jump into the situation that I'm telling you the story of today. Here's a simple system. This thing publishes scientific papers, and it has been operating well since 2017, so well that it has been outsourced, and some other company is developing features on it, maintaining it, who knows. But suddenly, there is a business shift, and there is a new business model on how to pay for papers and what you get in return. And so, my team is tasked with coming back to this system. And you can see there's a lot going on. But the business pressure is, this is where we need to showcase our new model, where we need to get more submissions. And every new paper you publish is thousands of dollars. So that's where we should have our focus. However, my team has been formed and then worked for a long time on a completely different system, an innovative product written in TypeScript, and many of us have never written PHP code before. I had, and I have some vague memory of what we were doing in 2017, but some people have entered the company without ever seeing it. Yet, that's your job now. So, how to face this situation? Most of all, my answer will be to face it as a team. So, bringing the work that needs to be done to an established team with a good culture and practices, rather than splitting us up and try to figure out who can do what. So, let's step back a little and see how a team can work together, or how we can decide to work alone. For example, when I was starting developing software in my bedroom in high school, you would have the typical situation of one programmer working on his own on a challenge. And so there might be various roads to get to the top of the mountain. Sometimes they're very tortuous and difficult. And as a lone programmer, you sweat a lot, but sooner or later, you Google what to do, you ask for help, and at some point, you get to the top. But when you have two programmers, that changes, because someone else can give you the answer to a question that you had and you might have left in a GitHub ticket for a day or two. Sometimes they can literally pull you up, like in a senior and junior engineers pairing situation. We work together and a person acquires a lot from the other. It can be bidirectional as well. You have two different specialties, like front-end and back-end. And so sometimes we find roads that are not so tortuous and difficult, but we get to the top quite easily. And probably many of you have done pair programming, but if you push this a bit to larger teams and larger problems, you get to this. It's one thing to play the violin alone, but it's another to put together different musical instruments to achieve the result that none of us could have done on his own. A front-end specialist, a database schema specialist, a full-stack engineer, a junior developer or a senior developer. But if the task is big, like facing a mountain of legacy code and making changes to it, then we need more brains on the problem, not fewer. So when I talk about ensemble programming, also known previously as mob programming, which has likely negative connotations in English, so better to think about as a musical metaphor. What do I mean is, this definition from Buddhizui, all the brilliant people, we are all brilliant, and we work on the same thing, typically a clone of a Git repository on someone's laptop, at the same time. So we are synchronously interacting. It might be at a desk in an office, it might be in a video call. we work on that same space, so we modify the same version of the code on the same screen that we all look at, on the same computer where we will run our changes and test them. And so, while in a pairing situation, there is a conversation going on between two people, the dynamics can get a bit more complicated when there's more than two in that video call or desk. And so there is this spoken, not really unspoken rule of trying to get ideas from people's heads into code, but in a certain way. And the way is it must be verbalized from someone. So you might have seen unhealthy pairing situations where someone is coding, has the control of the keyboard, and also tries to make changes, and you struggle to understand what's going on. And this can be amplified if you are in a situation with 3 or 4 people looking at the same screen. And what happens is we try to divide roles. There is a driver, there is someone who control the keyboard, and the metaphor is they are the hands, but they don't decide what's going on. We call them a naive driver. They take instructions. And of course, there's lots of different opinions about what to do, and the other people in the call room, they are the heads, they have the ideas, they want to make the next change, they want to write the next test, they want to go forward. But we have usually, and in my team this evolved quite quick as a strict role, a designated navigator, that is the voice. If there are multiple competing opinions, if there is a direction to be chosen, they are the facilitator that should be taking all of these nice ideas and figure out where to go next and navigate the driver to do something. Those names, driver and navigators, you might already have seen from pair programming, and that metaphor comes from rallying. The driver doesn't decide where to go on their own, and then you end up in Rome rather than in Milan. You have a navigator on the side that has a longer-term view of the road, and it can see where the curves are, where to slow down, where are we actually going, whereas the driver can focus on how the road feels and getting us there safely. So ensemble programming, all these violins and similar instruments playing together, is how my team has been working on for 4 or 5 years. And when we were tasked to come to a new situation, we wanted to keep the same practices on. And why? Because they help us a lot, and the more difficult the situation, the more they help us. So, coming back to the business problem, we'd like this new feature and these other two. This is a legacy system, but it's not like we have priorities of upgrading PHP. I wish, but what the business wants is new pages, new features, things that sell and bring in the money. And so, how do we make sense of it all? That's the same diagram as before, it hasn't gotten any simpler. This kind of diagram is optimized for a blog post to showcase that you're doing a lot of things. It's not optimized for working on it as a team. And one of the practices we brought in is to work on maps rather than diagrams. And what I mean is, a map is a model of the code, a high-level model, where you represent the aspects that are important to you, but most importantly, in our case, it's optimized for editing rather than for viewing. So there is a map for modules and their dependencies, a map for testing practices and how should we test different pieces of the code, a map for observability and what logs to write and what dashboards you have to see them. But the point is that this map should be owned by the whole team. It shouldn't be a tech lead like me or an architect that has to change them all the time. And they should be optimized for the team to add the maps that they need and the information that they want to represent here. Collective ownership, much more important than the perfect format. This, it doesn't tell you how to operate. This, you can store information ticket after ticket on what you have found that works. So we started building these maps piecemeal as we were going through the code and understand them, one piece at a time. But a typical pattern for these situations that you would use if you go into a new company or in a new team as an individual is deploy a change on day one. So take a bug fix, something simple. This button is blue, In a certain corner case, it wasn't blue. No button was colored. That's a bug. Let's fix it. It's very simple, probably. If you have someone familiar with the system, they'll do it in minutes. But as we operate on it as a team, we discover a lot about, we need to run this project locally. We need to test changes. Once we have changes, they will need to be rolled out to production. How long does that take? How can we observe that? Can we see some logs? So you take a very simple change and you use it to learn about the system and also the deployment process to that system and how to monitor it afterwards. That's the first pattern to apply in these situations. All real screenshots. Another thing that we do in an ensemble, which might be controversial if you're used to a pull request model, is trunk-based development. There is one main branch of this repo, and all the people are here in the room. So who should be doing code review if we open a pull request? We are all here anyway. So we break down that code review, and it's performed essentially every 5 seconds. We choose the name of a variable, and the other people have to agree on it. We choose the name of a function, and other people have to agree on it. Have we written enough tests? Well, we all sign off. We are all seeing the same code right now. So this environment of having all the relevant people around that are authorized to make a change enables you to do trunk-based development very well. You commit to main, no pull request, no branches, and whether you are doing a refactoring or whether you are doing new functionality, it goes to production straight away. No waiting. And as we did more of this and started to learn about the different repositories to touch, we tried to all put it together. And another pattern to apply is what we ended up calling, not the tracer bullet, because that sounded violent again, like a mob doing tracer bullets, calling it a torchlight feature instead. So there is a mountain of fog or legacy code, and you need to shine a light through it. It is usually organized in some vertical slices, systems depending on other systems. And so you shine this torchlight and you say, light, go through, and let's go through the content delivery network, through the journal repo, which is a front end, through the search repo, which is a microservice written with Elasticsearch. And we would like to achieve a feature that touches all of these places because it let us learn not just about some code in the abstract, but how the systems integrate together. So we write a failing test that describes what pages should be changing. And we write enough code in there to require a pull of a service in the backend, like this search one. So we tend not to write unnecessary code, because we do what we call the outside-in development. We start from what the user sees, and we go through the system not by arbitrarily refactoring or upgrading something, but by only taking the next step, writing the code that is necessary for the previous layer. And this torchlight brings us to understanding how the systems work together. So these are a few patterns of operation that can be applied very well in a legacy code situation. And now we talk a bit about the philosophy here. So we are doing trunk-based development, means we are committing very frequently. We are doing lots of small changes. And in agile software development in general, if you compare it to the hypothetical waterfall, what that means is that we acquire a little bit of value all the time, rather than working on a branch or on documentation or something abstract for 6 months and then shipping it with a big bang release, which is what you see in the blue and orange curves. Doesn't matter what waterfall does, but what matters is what we do here. And so if you make many small changes, you have to really optimize your tools and practices to support small changes rather than one release every now and then. So rather than a big code review on a pull request, we optimize for running the tests very easily on each machine. So when I say here, agile is sooner, not faster, what I mean is we get the value earlier, we get many small commits, and so you start to see positive changes early on, which can be an encouragement for the team. But it doesn't make the problems disappear. It doesn't mean that we can solve the problem faster necessarily. We still have to write the code that will solve the problem, just piecemeal. No magic solutions, but how can we compress that curve? We need a process where getting to a commit becomes progressively easier. So if you have a test suite that runs in 10 minutes, that means every commit will take at least 10 minutes. Realistically, it will take hours because you will run those tests very often. And so, in practice, what does this mean for a team facing a repository that they haven't really seen before or that they haven't operated on before? I describe this in terms of makefiles, but it could be your tool of automation, whatever you fancy. Makefiles are very portable across Linux, Mac, and other situations. So there's always make available on every person's laptop. Always have a target. We called it make check, running a subset of fast tests. Why do I say subset and why do I say fast? A subset because running all of the possible tests that have been added over the years with the instability of legacy code and its performance might be prohibitive. It might be something that you want to leave to CI as a safety net rather than something you run local. Why do we say fast test? For the same reason, because I'd like to run this make check every few seconds. Every time a change has been proposed by a navigator, I should be able to get some feedback. But I have to trade off how much feedback I can get with how quickly I can get it. And I want to get some feedback really quickly and have to leave, by necessity, the rest of the feedback to CI. If we break CI, the whole team is here. We'll just fix it. Also, for the same kind of feedback, I need a target that we called make dev. It should start the application. It should have a sort of empty database, and it makes me able to iterate on visual changes, to test the code locally in an exploratory testing form rather than automated testing form. So I see what the visual changes I'm making, and it sounds easy, it sounds trivial, but when you go into a legacy code situation, you might have to put together 10 different repos to see them working on your machine. And that's the first problem to be solved, because if we don't solve these two problems, running automated tests and exploratory testing locally quickly, then your commits will take hours, and if every commit takes hours, then cleaning the code becomes impossible. A refactoring of 10 lines I just won't do, because the transaction cost is too high. I need to make the cost of each commit very small. Similarly to make dev, to get to habitable code, as we say it, I would like a make prod target as well. Very similar, but instead of starting for an empty database, have a subset or a big dataset coming from production that allows me to see some situation that would otherwise only happen in production. In this example, we were talking about scientific papers, so copying the data about those papers, so rather than seeing a listing with a few of them, I will see thousands of them and see UX problems that I might not see otherwise. And this should be trivial, right? But in legacy code, nothing is trivial. But a requirement is that these targets should be portable. They should be running on everyone's machine. Our typical workflow will be that a driver will code for 10-15 minutes, we will get to a commit, and then we will rotate roles. So if someone was having control of the keyboard before, someone else will check out the code, and they will have to run it. This portability, in particular, we run into problems because of Apple Silicon, and how an ARM processor wasn't exactly meant to run code from 2017 that was built for AMD 64. And so it took some work to make all of these run on Linux, Apple old style, Apple Silicon, but it was all worth it because we then came to cycles of 10-15 minutes where everyone could do everything. And you don't need to wait for a particular person with a particular tool to do a particular change. So this kind of style of working tends to remove blockages, which are one of the major wastes of time. It doesn't make you solve the problem faster, but it removes the time in which you're waiting on someone else to review, to give you the right information, to approve what you're doing. The results of all of this are, when we took over some of these repositories, you will see one big pull request being merged every few days. And what you will see instead is 20, 30 small commits ticking away at the problem, whether they were building a page piecemeal or whether they were improving this habitability, introducing new targets, whether they were doing refactoring. But you will see constant progress, which is very encouraging. Another thing we found on some of these projects, particularly the front end, was 40 open pull requests that will probably never see the light of day. If you think about all of the hours that have gone into those pull requests, accumulating over the years, they will never be merged because they become out of date. That is a massive waste. But if you work as an ensemble, you work on main. Everything you produce must be broken down into small pieces and shipped directly there. No large refactoring that will never be completed. So eliminating those delays, our value started to go to production hour after hour, day after day. But most of all, and this is the big point of this talk, we can talk about code and its metrics, we can talk about processes and how this is in a lean way, more efficient in some sense for the business. But most of all, the value is for the people, a team of developers where, firstly, someone had never written PHP before, they've worked for a few months in this environment, being encouraged, considering it a new mission, a new challenge, rather than a panicking situation. And we saw these junior developers being able to navigate someone else joining the team that was new to the project. So the perfect handover where rather than having the bus factor of a few people that know everything, you expand that to a whole team where everyone can perform all roles, and when there is someone new coming in, they can be onboarded by everyone. And the safety of working in the team, its practices, and how people can come in and join rather than panicking, that's the big result. Thanks for your attention.